Okay, so we're on page 90 of the note spiral, which is the binomial distribution scenarios. All right, suppose that the probability of having a defective item is 0.3 given a box of 5 light bulbs. All right, so this right here, they're telling us our probability of success, P, is 0.3. So our probability of failure is going to be 0.7, which is just 1 minus 0.3. We have 5 light bulbs. So this is going to be my number of trials. So out of 5 light bulbs, what is the probability of having 0 defectives? So this is what my work is going to look like. If I want to get credit for this, I'm going to go 5, choose 0. And then I'm going to go 0.3 to the 0, 0.7, which is a probability of failure, to the 5th. Now, real quickly, here's what happened. I wanted 0 successes, so these two values will always be the same. So this value and my exponent here is the same. And then 5 minus 0 is 5. Now this right here is, I know I have a specific number of trials, and because I have a specific number of trials, this means I'm working with a binomial. And in this case, we have trials is 5, probability of success is 0.3, and my x value is 0. All right? So, and by the way, this gets you no credit. You have to show this. Have to. All right? So here we go. Second vars binomial PDF. Trials is 5. P is 0.3. X is 0. 0.16807 or 0.1681. And I should have said this was a PDF. And here's how I knew this was a PDF. I knew it was a PDF because 0 is a specific value. It didn't allow for multiple values, it only allowed for specific values. And by the way, we're going to start off by doing a bunch of PDFs and then we'll switch over to CDFs. So what is the probability of having 1 defective item? Well, I still have 5 light bulbs. So now I want 5 light bulbs. I have 5 light bulbs, but I want 1 to be defective. So 0.3 to the first, because these values are always the same. This is the probability of success, and this 0.7. 5 minus 1 is 4. Once again, I have a specific number, so this makes it a binomial PDF 5.31. And I'm just writing this down because that's what I'm going to be putting into the calculator. So second vars binomial PDF, trials is 5, P is 0.3, my X value is 1. And I'm about to speed this up a little bit, so 0.3602. So what's the probability of having 2 defects? Once again, we have a specific number of trials. Specific number of trials makes it a binomial. Please don't forget that. So 5, choose 2 successes. 0.3 squared, 0.7, 5 minus 2 is 3. We knew it was a binomial because the specific number of trials. It's a PDF because it's a specific singular value. So PDF 5, 0.3, 2. So second vars binomial PDF, change my X to a 2. And I get 0.3087. Once again, 5 trials. So a specific number of trials, so that lets me know it's a binomial because I have a specific number of trials of having 3. So it has to happen on the 3rd trial because that's a specific point, that's a PDF. So 5, 0.3, 3. And setting this up, 5, choose 3. There's my combination that we talked about previously. 0.3 cubed, 0.7, 5 minus 3 is 2. All right. So second vars binomial PDF, changing this to a 3. And we get 0.1323. 4 defective items. Okay, once again, we still have 5 bulbs. We have a specific number of trials. This makes it a binomial. Right there, we have a singular value, so this makes it a PDF. 5, 0.3, fourth trial. These are my x's. All right. So 5 choose 4, 0.3 to the fourth, 0.7, 5 minus 4 is 1. Second vars, binomial PDF, change this to a 4. 0.0283. Probability of 5. So binom PDF 5, 0.3. So this is going to be 5 choose 5, 0.3 to the fifth, 0.7, 5 minus 5 is 0. And I get 0.0024. What is the standard deviation expected number of defects in a box of 5 items? I'm going to start off with the expected value, which is going to be NP, which means 5 times 0.3, because my trials is this, equals 1.5 defective items. Now, the fact of the matter is, we're not going to ever have 1.5 defective items. When I open a box, I'm either going to have 0, 1, 2, 3, 4, or 5 defectives. But on average, in the long run, if we did this over and over and over again, we'd expect to have an average of 1.5 defective. So if I got really bored and opened a million boxes, I expect to have 1.5 defectives. All right. My standard deviation follows this formula, NPQ, which in this case is going to be the square root of N was my trials. My probability of a defective is 0.3, and the probability that it wasn't defective is 0.7. When I do that, I end up getting the square root of 1.05, which equals 1.0247. All right, we're going to continue with this scenario, so we're going to move on to page 91. So 91 says, first question is, what is the probability of having no more than 3 defective items? So we're still working with the same probability situation, where 30% are failures and 70% or 30% are defective, 70% are not defective. What's the probability of having no more than 3 defective items in a box of 5? This right here tells me once again that I'm working with a binomial because I have a fixed trials. But it says no more than 3. That means it could be multiple numbers. So I'm going to make a number line, and I highly recommend that you do this. My students who take the time to do this, and you can see that it only takes about 3 seconds, score a lot higher. So no more than 3 means it could be 0 defects, 1 defect, 2 defect, 3 defects. Please note that with the geometric, we start at 1. With the binomial, we start at 0. I'll say that again. With the geometric distribution, we start at 1 with our number line. With the binomial, we start at 0. All right, my trial, and so since I have multiple values, this is going to make this as a CDF. I have 5 trials. My probability is still 0.3. And the highest value I circled is 3. So really what I'm doing is I'm doing a PDF of 0 plus a PDF of 1 plus a PDF of 2 plus a PDF of 3. And you can see that that's going to get real cumbersome real fast. So this is where we can use the bookends again. And remember, with the bookends method, we're always going to start with the smallest one, and then we'll do the largest. So we're going to do a PDF of 0 plus a PDF of 3 and put plus dot dot in the middle. So my work shown in order to receive credit is 5 choose 0. 0.3 to the 0, 0.7, 5 minus 0 is 5, plus dot, 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 plus. This is going to be 5 choose 3, 0.3 to the third, 0.7, 5 minus 3 is 2. That will get you full credit for your work shown. This is what we'll plug into the calculator. So here we go. Second vars, binomial CDF, trials is 5, P is 0.3, x is 3, and we get 0.9692. So the probability of having less than 3 or less defects in a box is 0.969. So about 97% of the time we expect to have 3 or less defective items. What's the probability of having at least 3 defective items? Anytime I see the word at least, I'm thinking 1 minus. We have a box of 5, so we have a specific value, all right? Now, anytime this is 1 minus, so I'm going to put a 1 minus, but this tells me my number of trials is right here. So 1 minus, because I have trials, I'm going to go binom. And so I'm going to make my number line. And my number line says 0, 1, 2, 3, 4, 5. And I can have at least 3. That means it can be 3, 4, or 5. It can be 3, 4, or 5. So that's multiple values, which tells me this is going to be a CDF, a cumulative. All right. And 1 minus the binomial CDF, and I don't guess I need this, but I need this parenthesis here. We have 5 trials. We have a probability of 0.3. And the highest, and this is where we get weird. We're subtracting. Because we're subtracting, we're going to subtract the highest value we don't want. The highest value we don't want happens to be 2. Now, I just want to pause for just a moment and explain why. I want 3, 4, and 5. So consequently, I'm not going to subtract out that 3. I know that's what people think about, but it's like, no, I want the 3. If it's circled, I want it, so I should let you have what I don't want. So this is what I don't want. All right, and I'm also going to pause for just a moment and talk about this 1. This 1 comes from something else, because really what we're doing is the binomial CDF of the highest minus the binomial CDF of the lowest. So if I go second vars binomial CDF, and I change my x value to 5, because that's my highest value. All right. So 5, probability is 0.3, x is 5, and I get 1. And the reason that is because the CDF is the sum of all the PDFs. So the PDF of 0 plus the PDF of 1 plus the PDF of 2 plus the PDF of 3 plus the PDF of 4 plus the PDF of 5 equals 1. So this 1 is the CDF of that. All right. So if I added up all if I added them all up, I would get 5. All right. So this is where that 1 comes from. Now, and then this means it's like we have everything because it's a valid probability distribution. So the binomial CDF of 5 minus the binomial CDF of 2 is what we're actually doing. So I'm going to go ahead and write that down. You don't need to for a test or quiz or ever, but this is what it means. Binomial CDF of 5, 0.3, 5 minus the binomial CDF of 5, 0.3, and we're subtracting out what we don't want. That's what we're going to do. That's what we're going to do on the calculator, but we're just going to do 1 minus. All right. So this is the way you set it up, but this is not going to get you credit. This is the way you plug it into the calculator, but that's not going to get you credit. What's going to get you credit is the PDF of 3 plus the PDF of 4 plus the PDF of 5. So 5, choose 3. And 0.3 to the third power, 0.7, 5 minus 3 is 2, plus, plus, 5, choose 5, 0.3 to the fifth power, 0.7 to the 0 power. Now, some of you are probably saying, you know what? I don't mind doing the PDF of 3 plus the PDF of 4 plus the PDF of 5. That seems fairly easy and it makes more sense to me. That's fine for this particular problem, but what if you had to do it 20 times? All right, so you need to understand that you need to be able to do it this method, all right, right here, as opposed to just the sum of all the PDFs, because you'll run out of time if you do the sum of all the PDFs. So here we go. 1 minus, because that's what we said, 1 minus second vars binomial CDF, trials is 5, our probability is 0.3, and the highest number we didn't want is our X value, which happens to be 2. I'll put an X there so we don't forget that. Okay? And so when I do that, I get 0.1631. And this right here would be a full credit response, right? That right there would be a full credit response. What's the probability of having 2 to 4 defective items in a box? Okay, 2 to 4 defective items. So I'm going to make my number line 0, 1, 2, 3, 4, 5. So 2 to 4 is that. All right. So I'm really going to do, and because I have multiple values, this means it's going to be a binomial CDF. So I'm going to do a binom CDF. Hope I gave myself enough room. 5.3. The highest value is a 4 minus, and by the way, up here we had a 5, which was all of the values, and that's why we got to cheap and use a 1. We got to shorten it. Now we're going to have to do a binom. Of course, I did not leave myself enough room. Binomial CDF of 5 trials, probability is 0.3, and we're subtracting the highest value I don't want. I wanted that 2. I want 2, 3, and 4, so the highest one I don't want is a 1. So this X is a 1. All right? So work shown. It's the sum of the PDFs. So 5 choose 2, 0.3 squared, 0.7, 5 minus 2 is 3. Please remember, correct answers, no work, gets no credit. All right, correct answers, no work, gets no credit. And then 5 choose 4, 0.3 to the 4th, 5 minus 4 is 1. All right, so here we go. The CDF of 4 minus the CDF of 1. So second vars, binomial CDF, X is 4, minus second vars, binomial CDF, X is 1. And then we end up getting 0.4694. All right, and that will take care of that particular scenario.